Hello, everyone. So you may notice something wrong with this title. First, well, it's obviously a clickbait. It's the last session, so I was trying to attract a bit more people. I know it will be hard. But the second thing you may notice, if you know the two different technology there, Cassandra and Solr, is that, well, how can you merge them together? That seems a bit strange. It's kind of a different way of storing and retrieving data. And you're right. But the main problem and the main challenge here is that storing and retrieving data is hard. Obviously, it's not hard if you tell that to your wife, it's not going to work. Oh, I lost my watches. Yeah, storing and retrieving is hard. But it's hard in our line of business when we have to store a lot of data and we have to retrieve and search through that. Because we need to look at different things. We need to look at, well, what kind of data first? Is it relationship? Is it structure, unstructured? Is it a graph database? Is it document? What about transactions, scalability, distributed, performance, resilience? All these kind of concern. So today I don't want to give you an answer for all these questions, but I will tell you a story that may help you to raise some concern or raise some maybe possible solution for that. So this is a story about problem solving, engineering, and innovation. So just a few words about me. My name is Benoit Doumas. This is me on the picture with my daughter at the hackathon that we did in Budapest. So I'm currently leading the Budapest development team. It's a new office that we have. And I'm also part of this Aladin group there, which is basically the platform that manages all our investment. We'll just come back to it. A bit more background about me. I've been using Java for quite a while, and I'm not sure if anyone remember when we used to have in applets in browsers. I used to start with that. I just learned that applets is going to disappear from browser support, but that's all right. Things are moving. So I've been using Java for quite some time. I've been moving around the world. I was in Singapore, then I moved to Budapest. I think I used to think that Paris is great and Budapest was amazing, but I really like the energy I've seen here in Kiev, and it's really a pleasure to be here. A bit more about BlackRock. So BlackRock is the largest asset manager in the world. That means we have really a lot of scale issue. We need to rethink about numbers. We have 6.3 trillion of assets. That's 6 and 12 zero. And we have this new office in Budapest as well, but we are a global company. So Aladin is our platform that manages everything that we do. We build it from scratch, and we use open source, and most of the backend is built in Java. The thing interesting is that we also sell Aladin to external company. So basically, BlackRock has two businesses. One is the financial business, and the other one is a software business. But let's start our story. So we talked about two contenders to solve this problem or approach this problem of storing and retrieving data. I'll give you a bit of insight about the first one, which is Cassandra. Cassandra is a very popular key value store tabular database. As such, it has natural ordering, no relation, no ACID transaction. But it's very fast, and it's very resilient and scalable. So one of the biggest strengths really is this linear scalability and fault tolerance, which is very useful when you have to manage a lot of throughput, a lot of writes. We, at BlackRock, use it very early on. The biggest use case was to manage our trading systems. You can imagine that we process really millions of transactions per day, and we really need rock-solid resiliency. Currently, we are around at like 100 writes or 200 writes a second. So that's pretty heavy. Cassandra is also very widely used by the industry. I think Netflix and Apple use that as well. On the other side, we have Solr. Solr is really a popular search engine, enterprise search engine, allowing distributed search, full text search, real-time indexing. It's powered by Lucene, which is also an open source library for search. And the main competition is Elasticsearch. You may have heard about that. So we use Solr a lot at BlackRock We use it for product search, for asset search, for transaction search. We have around 30 terabytes of data with that, and 19 trillion of document. So what happens when you have really option for developer to use to store and retrieve data is that first you want to start to prevent some bad behavior. So let's see the kind of bad behavior you want to prevent. The first one is really the person who want to use NoSQL but is still addicted to SQL. So these people want indexes. And to do that, they use something called secondary indexes in Cassandra, which is very not efficient. There's a lot of performance issue. Then they realize also that maybe I need transaction. Actually, I forgot about it. I need like consistent transaction. And they start to add Zookeeper. I'm not sure if you heard about Zookeeper. But that works, but it's not so easy to integrate. And the biggest horror is when people start to do join within their code to simulate join that they cannot do on the NoSQL database. Really, it's something that you need to ask yourself, is it really the good use case that you have for your particular application? Writes are cheap, but retrieving data can be really expensive depending on how you do it. On the other side, in the search space, you have also some common bad pattern that you want to avoid. Really over-customization, because search engines are really flexible. You can control, tweak it. You can create your own custom query parser, or you can really extend a lot of the component and basically reinvent the wheel. You have also a lot of over-optimization, and that's around, for instance, preloading all your queries. It's okay to auto-warm up some of the query for the search, but if you load 5,000 of them, that just creates a lot of performance issue. The cost of indexing at each commit is really heavy if you have to do that. And again, one of the biggest problems that we can see is adding attribute, adding a lot of attribute to your Solr schema. Some people want to do it because they say, well, no, if I start to search, maybe I need to search all these documents, but add some extra data. So it becomes more like a data store, which is not really meant to be. Another common behavior that touch both area, the searching and the storing, it's the teams that just want to move fast and break things because they read about what's happening on Facebook. Well, in Facebook, we know it's not really working well these days. But in that case, is for instance using flexible schema to extent that actually there is no more consistency, or they don't really think through and duplicate a lot of data. And in the end, what you want to really avoid is to have too much technical debt. It's good to move fast, but you need to move fast and rethink at how to do each of the steps. We have seen also some good pattern emerging, especially within the team at BlackRock. One thing is that we need to really write a lot of data, and we need to search across these data. So some of the teams started to keep the data store and the search engine in sync. And they did that quite manually with rudimentary tool like batch, push all the update to the store and to the search engine. So it really raised the question, why cannot we get the best of both worlds? And that's the challenge that we ask ourselves, and we started to look at how to solve it. Because on one side, it looks very complementary. We have Cassandra, where the application server will do some simple operation, your put, your get, your del. On the other side, you have application server that want to search and index the data. But as a key value store, tabular store, Cassandra is not really optimized for flexible search, and Solr is not optimized for storage and resiliency. So putting them together seems like a good match. And that's what we did. We created this store called Aladin Data Layer. Obviously, everything that we do in BlackRock has this Aladin word because that's the name of the platform, and it needs to have 3 letters, so sometimes it's a bit difficult because you have a lot of different frameworks that want to compete for these 3 letters. But the Aladin data layer, ADL platform, it's really to have a lightweight application on the top that allow all the application server to connect both to the Cassandra and the Solr. And we wanted to take care of everything, to just have to declare your schema once, will be pushed to both Cassandra and to Solr. And you have to maintain the replicacy between the two. So in terms of just component of what we want to build to make it very useful for developer, it's really first having a DDL, a data definition language, where you express how the store will look like, how the indexes and the search indexes will look like. On the other side, you will have to provide a client library, so for allowing developer to access the both data store at the same time. So an API, connection management, authentication, maybe additional indexing feature, activity tracking, and support of different language. So Java, of course, maybe other language. And once you do that, you also want to provide tools for developers. So we really thought carefully about that because the ecosystem of tools for NoSQL database is usually pretty poor, especially also for development and operation. So that's what we provided. We built a studio that allows you to do queries on your data store, extract and load if you have to do migration, release tool to make it easy to release, also some monitoring, but also for operational team, because when you have an enterprise application, you really need to think really about the operation. So we have capacity management that will tell us when we need to scale. And we have, of course, a simple way to backup. So because if you have 2 data stores, then you kind of want to maintain them in sync. You want to also have a consistent way of doing the backup. So in a nutshell, ADL, the Aladin data layer, is to be a fast, scalable, highly available data store, putting both Cassandra and Solr together into integrated services. And the aim is really to improve resiliency and scale for both kind of use case and to make life super easy for developer and to increase really the operational efficiency. All right, so but that sounds good, but how this was done? And just one word of caution, I am not the one who built it. I am one of the users of the platform, but I find it fascinating. That's why I wanted to share the story. The people who build it are very smart people at BlackRock, distributed around the world. So in the high level, it may seem as easy as ABC. So first, you need to create an abstraction of your schema that will then generate Cassandra and Solr native schema, build a table and the collection automatically, create a lightweight library on the top of that for your application to access both, and do some replication. Sounds easy, but actually, if you really think carefully about it, first, we, as an enterprise system, we don't have one instance of Cassandra or Solr. In fact, we run for BlackRock in 5 different data centers around the world, and we have around hundreds of nodes of both Solr and Cassandra. So we really need to understand the replication and the data flow strategy before doing anything, if we wanted to implement that. So let's go a bit deeper into that. This is a simple use case where you have one data center and another data center. You have the Cassandra nodes, which are C*, and the Solr nodes. So let's say we want to handle a write operation from an application server. What will be our strategy? Well, we know that Cassandra has a rock-solid resiliency capacity and also is able to do replication very efficiently. So we should rely on that. And we rely on the synchronous replication of Cassandra through data center. We use the asynchronous replication of Cassandra across data center. And this is really built in Cassandra. This is proven. This is very efficient. We could use actually the synchronous replication across data center as well. But for performance issue, because that's a cost to do that, we use asynchronous. And we direct all our application to one data center. All right, now how do you maintain consistency between your Cassandra nodes and your Solr nodes? Well, the naive thing was to put something in between, do a batch, or pull the data each time there is a change. And that's not very efficient. There will be a lot of overhead. You will need to access the basic Cassandra API. You really don't want to do that. You want to be as close as possible to the Cassandra engine. Fortunately for us, we discovered that there is something called the secondary index interface. And this allows us to create plugin within Cassandra. And as a secondary index needs to be alerted, push of all the modification that happen in Cassandra, this is a very convenient way to receive all these notifications and then manage them and push them to Solr. And that's what we did. We extended this second index interface and created a plugin within Cassandra. And very simple, each time there is an update, we get notified and we push it to Solr. And to make it simple, we push the same kind of behavior to all the nodes. All right, but then you tell me, if you do that, that means that Solr get all the notification all the time from all the nodes. Well, you're right. So to prevent that, we created a small plugin again in Solr to handle all these updates so that we take only the first one. So to recap, when a change happens, we rely on the internal working of Cassandra to be notified. And this is very low latency. Then we send a message to Solr, let Solr take only the first update. And we rely on Cassandra handling of multi-center replication, multi-data center replication to ensure that there is consistency across several data centers. And then Solr also do his own replication. All right, seems like we made it. But actually, we need to realize that we handle just a high level of throughput. We have, as I said, around 10 million writes a day, more than 100 writes a second. Can we just expect to send a message to Solr and the consistency will happen like that? Not really. Also, do we really want to send all the updates to Solr, even if we just take the first one? Maybe not. Maybe we should kind of group them together. So we need to spend a bit more time to look at this little ADL plugin, which at the beginning seems simple, but actually is not that simple. So zooming into the plugin, it looks a bit more complex than expected. So first, we have to have a journal, which is a blocking queue that will store all the update and ensure that everything has been processed and we don't lose any data. This journal will receive, because our code, our plugin extend the secondary index, all the write notification. We'll store that in a journal, and then we'll have a pool of threads that consume this notification to group them together and start to push them to Solr. So we do that to make it efficient than to have batch of update together that constitute a document that you want to push to Solr. All right, if it's a success, that's great. We delete it from the journal. Some things may happen. So maybe the Solr instance is down. Maybe there is some inconsistency. Maybe somebody has updated manually Solr for some reason. So you may want to retry if there is some issue. So we have a simple retry mechanism there. But sometimes it will happen that it's not retrievable, and there is a bug that can happen. So we need to just keep track of that because of the sake of consistency. So we have this write dead letter process that basically what it does is store these failure and push them to the operational team so they can later investigate what happened and maybe resolve it to maintain consistency again. And we delete it from the journal because that would be a manual process. One last thing that we need to do is, because we are running in the heart of Cassandra, you don't want to take all the memory. You don't want to make Cassandra crash because that will really impact your productions. So to prevent that, we have a spillover process that, if the memory, the journal gets too big in memory, we will start to write to disk. But also this is very handy if Cassandra crashes, or if there is a problem like truncate is commit log or something like that. And we'll be able to retrieve it and load all these from file. All right, so now we've seen that it's not as simple as we thought it was, but that seems to be working and is pretty efficient, actually. All right, the second thing now we need to think about is really creating an abstract schema and deploying it. So we have this way of really propagating the data and maintaining consistency, but we need to have consistency between the two, the Cassandra instance and the Solr instance in terms of their schema. So for that, we created a very lightweight schema that mixed together Cassandra definition and Solr definition. So the first part, if we go through some of the item there, is about consistency. And again, that's what we discussed. Consistency can be synchronous or asynchronous. So if you do, let's say, data center, you mean you want to have consistency within your own data center, but not within two data centers. So it will be asynchronous push. But this you can change it. You can have global, and then you have synchronous replication. You may have none, which means that you have asynchronous. That's to really handle high performance kind of application for write. Well, module is basically just a way to group repository because we have a lot of repository and we want to be a bit organized. So that's a convenient way to do that. Then you declare your fields, also very straightforward. You have the name and the type. Obviously, you want your key to be not null. And you can have also complex kind of collection. Next is about indices. So you need to define your store indices, your Cassandra indices. Like we have this primary index, which would be on user and created with range on created. Cassandra has two primary key structure. So user will be the clustering key and creating will be the partition key for range query. And then you will have your search, which is basically your index for Solr. In that case, it's very straightforward. It's just a simple index that will search from the first, the beginning of the string. An example will be, well, I want to search within content everything that contains BlackRock, and then you use this map capacity. So I will get this field metadata, and maybe one key is visibility, and I want to retrieve everything that is public. So that may be useful if you want to push some information on our public website. We just need to take things that can be public. Okay, so that's very basic. If we go a bit more than the basics, we can define everything that is possible to define with Solr. I'm not sure if you are familiar with that, but you can have composite key. In that case, we have a composite key on user, content, and tag. This will allow to search through all these fields. We'll have also the concept of indexer, which is basically to have a different way to search through a field. In that case, if it's a text general, it will be a tokenizer. You'll be able to search all the word within the content. And you can have some more complex thing where you use this map structure, for instance, to have an indexer that will use each of the different key to have a separate search. All right, so we have this generic abstract schema. Now the key is also to build some tool to push it, and that's what we did, because you want to have to push it both to Solr and to Cassandra. So this tool will consume the new schema, will transform it to Cassandra and Solr schema. First, we'll push it to Solr, because Solr is basically the slave of Cassandra in a way, in terms of replication. So you want it to be configured first when you start the replication from the Cassandra side. And then you create the Cassandra table and configure the replication from the schema. So it's pretty straightforward, but there's a lot of transformation to ensure consistency between the abstract schema and the two Cassandra and Solr schema. All right, the next part is really building a library, and you want the library to be very user-friendly for developer, so simple and light. Obviously, you want to use annotation, makes life easier for developer. So in that case, we have we map this class to a repository called comments. We have different fields that we just declare with an annotation. You can have a specific mapping. If you look at created date, that means that created is actually mapped to created date in the schema declaration of your data structure for the repository. And you can have also simple declaration for more complex structure, like a map of string. How you use it? First, you need to get a repository instance. In that case, what we have is a type repository, and that means that you use the annotation to do the mapping automatically and to have strong typing. You declare your POJO and you store your POJO. So very simple and straightforward. Obviously, if the key is already existing in the store, you will override the object there. To do a store query, which means a get in Cassandra, is also very simple. You create a query based on the index, because that's how you query basically Cassandra to make it efficient. And you can create some constraint, in that case on user and on the date of creation, or you can specify a range. And then you iterate through your result. So nothing really extravagant there. On the search side, which is more interesting, because we want it to be integrated, and that's where the power of putting the two platforms together come from. So you get a searcher, which will be a type searcher, because we have a type repository. You will get all your result based on the query. That's a very simple query there. We just search for some name, and you iterate through the result. So it's pretty straightforward. But you can have a bit more complex way of querying. You can have a Fluent API to build your query. In that case, you will add, I want to search all the user with some name, and the content will contain BlackRock. And you can go and iterate and get all your result. And there is two ways to get the result. This is the synchronous way, so you get all your result at once. In the example below, where you use actually a search string to query the search engine, then you use an asynchronous callback way of getting all your result. This is a real-life example where the team built a query to basically add some ranking to the Solr search. Just to focus on one item, which is really the power of Solr, this example is about querying all the organizations that are clients, for instance, of BlackRock. But because this is for a particular employee that querying that, we want to bump up, and what you see there with the 35 is mean you multiply by 35 the probability to bump up all the results. And we want it to be bumped because if this particular employee is basically on the team that manage this client, you want to have this search result appearing first. So you can do a lot of different things with that. It is very flexible. We didn't really abstract too much the Solr native API because it brings you a lot of flexibility as well. And one thing which is very useful is creating pagination. So, for instance, if you have an infinite scrolling kind of a web application, you want to be able to paginate and load all the data as it goes. And that's exactly what it does. So basically, you create a paginated search, and you define how many rows you want to retrieve. So just to step back a bit, so from this client library, the get operation, which is to retrieve something from the store based on the key, will go directly to the Cassandra node. And that's really the most efficient. But from the search operation, we put in between this little search server there. And that serves different purposes. So first is preventing, for instance, user to access things that they shouldn't access because we have some data that needs to be permission. So this enables that. To enforce also some guardrails in terms of not querying all the time, not overloading the node in terms of queries. And also to do some tracking in terms of performance because Solr track things like average query performance, but you want to maybe get a certain percentile of the search query that are impacting the Solr node and to be able to fine tune it like that. So we track everything in that particular server. Okay, in summary, so the aim was really to make it simple for adoption. And we implemented some very simple replication, which are optional, obviously. You can still use Cassandra without anything. And the consistency, but it's an eventual consistency, so it will happen over time. We have a simple, so that's done. We have a simple schema and query language, all right. We have an API in Java and C++ for now. We plan to extend it to Python. That will happen soon with complex collection. That's cool. And then you have a lot of different tools on top of that. So, all right. So what's the developer reaction within BlackRock? And we have 1,500 developers currently. Kind of a jump of happiness. That's what we wanted to expect. But actually, if you really start to analyze it, there is different order of consequences. Obviously, the first order is the thing that you expect, which are either, well, maybe they will use it, maybe not. We want to see that. And that's what we've seen. There were a heavy usage of the platform. This platform went live 6 months ago. Within 3 months, we had around, or more than 20 projects using that. We have around 50 new data stores. And really a sharp increase in Cassandra and Solr. So the feedback was really good. But then if you look at the second order consequences, it's a thing that you kind of think about it, but actually didn't take too much in consideration. And one thing that we had to do is really to put also some guidelines for developer to remind them, okay, even if it's very easy to store data and retrieve data, you still need to think a bit about it. You still need to think that it's not a SQL database. So think about your denormalization, your use case, what exactly you want to achieve. The second thing is you want to have consistency, but if you denormalize too much, you may replicate data in all different tables. So you need to really think of how you maintain consistency within that. And the third thing that we've seen is that, yes, search is always eventually consistent. And that means there will be a lag, because even if this little plugin that we have seen is there embedded in Cassandra, there is still a lag for the replication to Solr. Currently, I think it ensured to be within 30 seconds, which is pretty efficient, looking at the volume that we have. That said, developer will come with some use case saying, well, I would like to be real time. Well, it's not really possible. The next thing to think about is also the evolution cost. And you have feature requests, of course, from developer, but you have also the two platforms are the Solr and Cassandra is always upgrading themselves. So you need to be able to handle that. You need to be able to handle the load of work. And then the last part is really on the operation costs. As much as we reduce operation costs by putting all this together and have some nice tools, they still to have like really heavy support of this because more and more developers are using it, more and more projects are using it. And you need to train also the new joiner on the operation side because maybe they know Cassandra, maybe they know how to support Solr, but then it's a different thing, put them together with this customized platform on the top. And the third order of consequences is the thing that you didn't really expect and actually more fundamental change that appear within the company. And one thing that we looked at is that it starts to have really a lot of innovation. Why is because this enables people to try things and to really have the time to market much reduced. But to try things is important to have safety. So with the platform that will give them some guardrail, it helped them to try without disturbing too much the production environment. So one example that we have is in Budapest, one of the team was given the challenge to look at our CRM system. The CRM system that we have is very simple because it's not our core business, but we develop it from scratch. And the question was, shall we just buy Salesforce? It's a very common tool, and a lot of companies are using it. So we give them the challenge, say, well, you have 6 months to try to build something that will bring immediate value to the sales team, and to get to see if we need to invest in Salesforce or if we continue to build our own tooling. And basically, within 3 months, they come up with this little mobile application that use ADL, this data layer, to get all the data from the Aladin platform to generate insights for the sales team. And using that, they can go to their client and look very smart and give some good recommendation because they will get insight on what's happening within the market. So, and at the same time, they had this speed, they developed this in 3 months. So that's the kind of the application that they develop is basically a mobile application that give news about what's happening in the market and what news impact particular client, which is very, very powerful for salespeople. So all this, it's just an example of how it can be leveraged to increase innovation and time to market for teams. All right, and I say that this will be a story that may help you to think about your strategy for data storing and data retrieving. But at the same time, that's also something that we wanted to push there for the general public or general public of developer to give some feedback. Because we are thinking, well, maybe we should open source it. So please don't hesitate to give your feedback. We are available online, or you can reach me later on. Because we think that could be a tool that could be used by people outside of BlackRock. All right, thank you very much, Diakuyu, I think. And if you want to contact me, I am on LinkedIn, or you can also contact us on the blog there. Thank you. Do you have time for any question?
Thanks very much. Very interesting. One of the things I was wondering about, is there a chance, and I guess that there is, of there creeping in some discrepancies between the data in Cassandra and the data in Solr? If that can happen, is there a way to spot it? Is there a way to deal with it? Can you throw away Solr and rebuild it, for example?
That's a good question. So we have this target to be eventually consistent.
Yeah.
That's as you have seen, there is this mechanism of dead letter, basically, that sometime it happens, especially for the first iteration, that there is some bug or some issue, and they have to deal with the operational team. So, but what we have is, because of that, we know exactly which data is not replicated, and we will be able to correct it. So that's how we deal with that.
And you can guarantee that all the other data that doesn't end up in the dead letter is processed correctly.
Yep.
Okay. Cool.
And you rely also a lot on really the replication between the different Cassandra node, which will push the same update. And if the update is not there or different, it will be taken account by Solr. So because you have all this replication and the plugin is always pushing the updates, it will be consistent. You ensure consistency on this side.
So when a node dies, either a Cassandra node or a Solr node, and you instantiate a new one, will it automatically gets populated with data?
Yeah, and that's relying on both Solr and Cassandra own replication.
Okay, that's good. Thanks.
Thank you.
Hi, I just wanted to check if the records in Cassandra and records in Solr are they do they map one-to-one, or they are something like views of the Cassandra records?
So the schema is pretty simple. So what we try to do is really to map one-to-one to make everything simple and straightforward. So yes.
Thank you.
Hi, thank you. So everyone knows that Cassandra wasn't built to support like complex calculations and aggregation features, but at the same time, Solr does it. And did you add Solr to the picture?
Sorry, I didn't get that. Complex?
Aggregation and calculation, calculating different metrics or things like that, and making like groupings and calculating metrics over groups, things like that. And Solr can do it. But did you add Solr to the picture just to support searching capabilities, or you also like make aggregations using Solr?
Like I say, I'm not the one who built it, so this I will not be able to answer. The usage is pretty straightforward. We use it for search and to bump up some of the results that we think are more relevant in particular use case. In terms of aggregation, I'm not so sure. We can catch up later on that.
Okay. Thank you.
Welcome.
Hi. I wanted to ask you about the logic that you had previously to work with Solr and Cassandra in the same time. Did you have it in one application, so to update some document in Cassandra and after that to index it in Solr, or not?
So it was a bit organic. So each team has their different way of doing that. So some were just pushing from the application to both Cassandra and Solr, and basically kind of hope that consistency will happen. Some will have this batch in between. So basically rebuilding nearly from scratch every night the whole Solr instance. Mm-hmm. So they didn't really care to have too much latency, because maybe the use case was different. So you had really different kind of use case based on the team. So what we wanted to offer is a single, easy to use wrapping around the two platforms.
Okay, and probably you compared some performance for common queries that you had previously to Cassandra and to Solr with the previous way of implementation, with this. So in terms
of performance, because when you do a get, you just go to Cassandra, it's basically the same as before. When you go to Solr, there is a little overhead with this particular search server that we have, but otherwise it's pretty much the same as well. So we didn't change the way to retrieve data in both cases.
Okay, thank you.
Thank you. All right. No more questions? Thank you very much.